my colleague Niels here is with me, and together we will add some improvements to a little game jam project we have created. And I think we can just start by diving into that. So we were using Fusion for this game, mainly because we wanted to do something big, large scale. And as you know, Fusion is a good choice for that. So what did we... So what kind of game did we come up with, Niels?
Chicken Snake was the name
exactly.
of it, right?
Yes, so it's Snake, but with chickens. We thought that reconnect the theme, we wanted to have a little chicken family reconnect with each other. So that's what the game is about. So on our setup here is we have a very simple Unity project. There is just the basic elements in here, like a light. We have a ground plane, which you can see it is really, really big. And then we are using the network debug start setup. Niels, would you like to explain to people a bit what network debug start is about?
Yeah, just a quick intro. It's a prototyping tool that we include with Fusion, which makes it really easy to get started with actual gameplay work. So you can delay the whole application type of work until you have an actual working game loop. So it allows you to spawn a host and a client or a single player mode and get your scene up and running with a Fusion network runner in it and spawn the initial prefab. So it's just a way to get started really quickly.
So if we enter play here, we get this menu here, right? So this is just a super simple way to get started. It's perfect, honestly, for something like a jam here. So you should use it. You just drop in this network debug start and the GUI component, and that's it. And then you set up your network runner as a separate prefab. So here we have our network runner, and then we have a few scripts, which we will explain a bit later, but they listen to the runner callbacks. Then what else do we have in the scene? We have a camera. This is a very simple setup. We also already added a script for camera control. So this is going to be a top-down game. So the camera will just point at the player from above. And the script for that is basically a single player camera. So what we do here is we have a target transform, and then we just want to keep the camera at that transform plus a certain offset, right? So this is a super simple setup. We haven't yet gotten the time to make this multiplayer ready. So this is not integrated into the game yet, but that's one of the things we will do very soon. And then the last thing we have here is this chicken spawner, which spawns a bunch of NPCs all over the map. So we have 2,000 NPCs getting started at spawn. And what this does is, in this spawned function, it checks whether we are the server. Because if you spawn an object in Fusion and the server does that, it gets automatically spawned on all the clients, right? So you only need to do that on the server. And then we just spawn the chickens at a random position. That's all this does. So if we enter play, let's start first in single player. We can see we get our little chicken player here, and we can move around in like all directions. If you go back to the editor, we can see there are actually a bunch of chicken NPCs around us, right? So these are smaller chickens. And as you can see, we really have a lot of them. And then we have the player avatar. And the goal of the game is you can move around and you should catch this chicken. And as you can see, the camera is not set up yet, so just have to use the editor view. And they're all running away from us right now, which is very unfortunate, right? Can we get this? Whoops. So once we collect them, they get added to our chicken snake, which just makes them follow the main chicken. And that's really what the game is all about. It's a very casual, goofy kind of game. There is not really a competitive element behind it besides collecting as many chickens as you want. And I think we can dive a little bit deeper.
You mentioned that the reason for making this really big from illustrative purposes to show area of interest stuff later on, if we get that far. But let's see.
Yes, exactly. So why did we choose Fusion for that instead of Quantum, Niels?
Yeah, that's exactly because it allows us to have each client only care about a small part of the world. So even if we have 2,000 chickens, each client doesn't need to constantly get updates from all 2,000 chickens. They can focus on what's actually in their view.
Exactly. But right now, that's not set up yet. So when we run this, all the traffic, like the network traffic from these 2,000 chickens will be synchronized. And I think we can actually show that with another little tool. So first, we can showcase network debug start with a server and a client now. So before we were in single player mode, and now we have both a server and a client, and we're getting duplicate lights. We can fix that later. I just disabled one. So now we have one server and one client scene here. And I think what we can do is add these Fusion network stats.
At the bottom, it's a list.
Oh, yes, exactly. Do we need to...
You need the debug DLLs, I think.
I think I'm on the debug DLLs. Don't need... Whoops. Maybe I need to do it before I enter play mode. Could very well be. Yes, here we go. So as you can see, it's about 1,000 bytes per packet. And I think we are running at a tick rate of 20. So this is 20 kilobytes per second, which is a lot of traffic. I mean, yes, obviously it's working here on a local machine, but this is not the kind of traffic that you want to have in an actual production game that is running over a real network, right? So we will be using Fusion to optimize that. Before that, let's go a little quick over our NPCs and players we have here. So the NPC setup is super simple. We are using an art pack from the asset store. I think it's called Quirky Series. It was part of a recent Humble Bundle, actually, in case you got that. They have these super quirky little animals, and one of them is a chicken, so it's perfect. And we're using that visual. It comes with an animator. Right now, we haven't synchronized the animation, so it's just playing the walk animation. That's something we're also going to look into. Then it has a movement script, which what this does is it does random movement at like certain intervals of time. So one thing that is interesting here is that in a regular single player game, if you want something to happen for, let's say, 5 seconds, like we do here with this duration, then you can use a coroutine. But the Fusion approach is a little bit different, right, Niels? So why can't we use coroutines in Fusion?
Yeah, we want to use something that is synchronized across the network. If you start a coroutine, that's going to start on the client that starts it and nowhere else. And even if you do start on a different client, it's going to be off in timing. So what we generally recommend is the tick timer. which is basically just setting a target tick for when something is supposed to happen. So it's super cheap. There's no network traffic other than when you actually create the tick timer.
Yes, exactly. So that's what we're using here. We're also using fixed update network for the movement. And here, a few things are special about this. Since these are NPCs, we're only doing this on the server, right? So, or on the state authority, which in our case is the server. Because the server controls all the NPCs and their position, and then they get replicated to the client, right? So they don't need to run this movement code.
Yeah, that's an important point that we generally preach, that anything you do in fixed update networks should be networked. But that's, of course, only true if you want prediction. As long as you're running server-side only, all bets are off. You can do whatever you want, basically.
Exactly. So we have this tick timer here, and this is not networked, right? So if this was on a player object, you would need to network this because it needs to be predicted as well.
Yeah. You could have gotten away with just using a normal int if you wanted to, but...
Oh, yeah. I think here we might have... No, don't use a coroutine, not even in a case like this, but it might have worked, but no. So what this is doing is we're checking this timer, which we're setting for 5 seconds. And then every 5 seconds, we're going into this function here. And what this does is it switches our chicken from the moving to idle state. So we always move, then idle, then move, then idle. And we reset this timer, right? So we're creating a new timer. And we're saying, again, 5 seconds from basically now. And then if we want to move, we're searching for a new target to move. So we just get a random direction. And then we decide to move towards that. And then what we do each fixed update network, right? So this is this code. So when we're moving, we're just getting the direction. And then we're rotating like towards that direction. And then we're moving a little bit towards that direction. So that's like regular movement code that you would see in a Unity single player game.
You just noted in the chat that there's a different approach if you want to have a script that only runs on the state authority. You can actually do that with a tag. So instead of having ifs all over the place, you can have a single tag at the top of the class that just tells the future how to run it.
Oh, what's it called again?
I don't remember actually, to be honest.
Well,
it's not something I use a lot, but it's a convenient way if you have stuff like NPCs where most of the code in there will not be running on the client.
Yep.
I can look it up for you just a second.
So this is our NPC, and then we also have the player. Player is set up in a similar way. It has a different movement script, which I'm not on the player. This is the player. The player has a different movement script, which this is using Fusion input, and then the movement code is relatively similar. So this takes the direction based on the buttons you've pressed, and then it moves towards that direction, basically using the same code as the NPC. And then what the player also has, it is this snake, right? So here we have a bunch of snake parts. They're all hidden like beneath the head or the player chicken transform. So we're networking each part of the snake. So when you add chickens to it, an object, all we're doing is we're enabling or disabling the chicken here. I don't know why Unity decided to recompile here. So, and then the script which controls the snake, like how long it is this chicken snake. And this is a bit of a complex script. It's a bit long, so we're not going to explain it in detail. But essentially how this works is we're keeping track of all the transforms, and we're keeping track of how many chickens are in the snake, right? And then we can increase that count. And then each fixed update, we just enable or disable the correct amount of snake parts, so the little chickens in the snake. And then we also move the snake. And the movement is just that each chicken follows the one in front of it, right? So that's where we're at right now. It's already a playable little game, but we have a bunch of improvements planned, right? So let's dig into the first point, which is something very common where we have this camera, but it's not following the player, right? So pretty much every game needs this. We need it. So we need to upgrade this to solve this. And the way we decided to do this is to create a script which links up the local player object, so the one we control, with the camera. So we will create a new script, let's call it player camera enabled for some reason. Yeah. Camera. And then what we will do in here is, first of all, this is going to be a network behavior, right? So this is going to be on the player object. And then when we spawn the player object, so we use override spawn here.
Sorry. The font is really small. You can size it up.
Oh, yes, good point. Let's scroll in a bit. I think this is much better. Is it legible on the stream? Good. So what we say is when we spawn this, we check for whether we have input authority, right? Because that's true for our own player. It's not going to be true for other players. And then we want to spawn a camera and attach it to this player, right? There is a little thing here which is different from Fusion compared to like regular unit instantiation. We need to instantiate this into the runner scene. Why is this the case, Niels? So why do we need an instantiate like this?
Sorry, I was just trying to get the chat to work. I seem to be unable to reply to the public chat.
Oh, okay. Then maybe you can try directly on YouTube, but
yeah,
we'll need to figure that out.
Sorry, what was your question again?
So when we instantiate something in Fusion, why do we need to do this? When do we need to do this? Or why can't we just do it regularly?
Of course, the object needs to be instantiated on all multiple clients, network objects. Is that what you mean? Or you mean by we're running multiplayer? Is that what you're referring to?
Yes, exactly right. So,
so as you saw before, we had multiple clients running inside the Unity editor. So we need to be able to address the correct scene.
It's really the same as instantiate for the camera prefab, but we are doing it in the correct scene, right? So Fusion controls scene loading. You might have multiples of them. This is just the way to do it with Fusion. And then what we said on this top-down camera, we have a target. And once we set that, we are all good. So what we will do here is we will say that the camera target is equals, we'll need another transform here, which is, we want the interpolation target, right? So we'll set it up in the editor real quick, but the important part here is that we want the camera to follow the interpolated visual of the network object, because that one is in sync with the Unity update or render rate, right? So we have our little player camera here. We can return to Unity, let that compile for a second. Let's just add it to our player avatar. So we need the camera prefab, and we need a target to follow. And in this case, we have this head, which represents the main chicken. And this is a network transform with an interpolation target. And this is what we're interested in, right? So this is just the visual. It's not the collider, stuff like that. And we want to follow the visual. So we're dropping that one in.
This is a common mistake that you end up following the actual network object, which snaps to a specific position. So it's not smooth.
So now we remove the camera from the scene because it's going to be spawned, instantiated better by this player avatar. And now if we enter play mode, you can see that the camera will follow the player. So don't know why we got the little chickens now, actually. We messed something up here, Niels. I don't know what we messed up.
It may have been saved along with the scene.
Hmm?
Do you have any code running in editor mode?
Editor mode?
I mean, if you have code running in the editor mode, it might have saved the actual, the previous...
Oh, yeah, maybe. Anyways, the camera now is following whichever runner we have control of, right? So when we say the host, we're following the host chicken. And when we switch this to the client, as the client, we're following the client's chicken, right? So each player will have the camera follow their own player object. Just gonna check again whether the snake still appears, because that shouldn't happen. Oh, we're fine now. Don't know what happened. Also, what you see here, where there is a delayed object behind the original, that's when you run both at the same time, right? So if you start in multi-peer and you have a server and a client on, then you see both of them on the screen. And this can be very practical to debug something, right? Because you see what does the client see, what does the server see. And then one thing which gets annoying here is the light, which gets duplicated. And the way Unity works is Fusion creates additional scenes, but these are not separated for Unity by its own. So the lights, Fusion, like Unity thinks it's just one scene with two lights if you load additional additive scenes in. So what we need is a runner visibility node, and this controls objects like this. So what we're saying here is we would like to have this light only on the input authority, if possible, so that it's going to be disabled on everyone else. That just makes it a little bit nicer to deal with these things. So we would do the same thing with your UI components, stuff like that, just so that the game actually looks playable. Okay.
This is not as a debug feature. It's not really for production as far as the visualization goes. There's another aspect of it, which is running multiple servers inside the same process, but that doesn't include all the visibility stuff. Normally, it wouldn't have anything visible at all in that case.
Exactly. This is just for debugging. It's a super practical tool. You should use it, or you should find some other way to iterate quickly on your builds. You should test often your multiplayer game with actual multiple players, because that's really how you find the bugs or what's going wrong. And then we got a question from the stream chat, which is whether the visibility nodes, do they need to be removed for production, or can we keep them around? Do you have a good answer to that?
Remove, no. No, they should be automatic.
Okay, so you can just keep them around and you should be fine. So the next thing we want to do is, if we enter play again and look a bit closely, we can see that we are not really animating these chickens properly, right? So they're always in this little walk animation, even if they don't move. Now that's not cool, right? So we're gonna need network animation. Now, animation is a bit of a tricky topic, right, Niels?
Yeah, sure. If you want to be tick accurate with every single frame, then it gets really complicated. But for this, I guess we can just get away with just turning it on and off when they start moving.
Exactly. So what kind of game would need tick accurate animations? Or
anything where fighting games, first-person shooters, where you care about whether you hit someone in the head or on the foot, in those cases, it becomes really important to know where exactly each bone of the animation is in a given tick. Of course, fighting games are for the same reason.
Yep, fighting games, FPS are great examples.
Yeah, kind of ties into the whole lag compensation issue as well.
Yep.
Where these details start getting really important.
Essentially, what you need to ask yourself is, does animation affect gameplay? And if yes, it needs to be part of the gameplay. So it needs to run in fixed update network and stuff like that. In our case, as you can see, the movement just works. It has nothing to do with animation. So we're going to keep that separate. Now, there are still different ways to approach this with Fusion. One is there is this network mechanism component, network mechanism animator, which synchronizes animation. But we're not going to use that today. We're going to do something much simpler. But this is a viable approach for many use cases, besides the complicated ones where you need tick accuracy, like the FPS lag compensation use case. There, you would need something else. So we will implement our own today. Let's call it chicken animation. This is gonna be a super simple implementation. What we're going to do is we're gonna, first of all, this is gonna run in render. So we need simulation behavior because we wanna do this on each render. And then what we do is we animate the chicken based on its velocity, right? So how fast is it moving? And then we are animating it based on that. So first, we'll need to capture the last position, right? So you're saying vector 3 last position, and then at the end of each render, we're capturing this as the transformed position. And then we can calculate the difference or the velocity here, right? So we can say difference and to get the velocity, we actually need to divide this by delta time, right? Because so this will give us how fast the chicken is moving, basically. And then what we can do is we can just update our animator with that value, right? So this here gives us a vector velocity. We can get a magnitude from this, and this is our movement speed. So we can link an animator here and then just say animator set float. I think we called this one speed. I might need to double check. Then we pass in speed, so the velocity magnitude that we're moving.
Even if you wanted to do this just using the good old legacy animation player, or you want to use playables, I mean, you already have the information needed to decide whether it's moving or not. That's the velocity. Then you can either choose to just play an animation explicitly, or like you do have just a set of float that drives an animation state machine. But you can really do it any way. Like Fusion doesn't really care about how you actually link your movement to your visuals.
Exactly. So the important thing here is really the understanding, right? So you drive the animation based from the state. In this case, it's our position, and the position is networked, right? So you take the state, and from that you drive the animation. And that's gonna work for most use cases, besides the one Niels mentioned before, like FPS, right?
I mean, they're essentially doing the same thing, just on a much more detailed level. They have to sync each and every single little bone, all the events that drive the bones.
Yeah, exactly. So now if you go to our chicken NPC, can go to our object with the animator, and this already has an animation controller. This is super simple. We have a speed variable, and then we switch between an idle and a walk animation based on the speed, right? So this is just a regular super simple animation controller. We're gonna add our chicken animation. That is already everything we need to do. So if we enter play mode again, we will get some animated chickens, hopefully.
Or not animated, as the case may be, when they're stopped.
Yes, so when they move around, you can see them. It's a bit hard to see because their animations look quite similar, but they like bounce their head when they move, and then they just idle around when they idle. So that's working. Yeah, the animation here is great. I love this. It's like a spring. And we just did it for the NPC. We'll also have to do it for the player. So there we have the head, the main chicken, which has the same animator. So we're just gonna do the same thing for this. And then for each of these snake chickens, we're gonna do the same. And these are a prefab, so we can just open the snake part prefab and add it here. So we have another animation. Voila, now we have a fully animated chicken snake. Now, one thing with Fusion is you can do something like this, right? Where this doesn't have a network object. It's just a prefab. So we fully support this sort of nested prefab where you can put network behaviors on them, and it's just going to be combined together into a correct network object at the end. So that's a very useful feature for something like this. I think we also can take the time quickly to show you a little bit how the snake looks like now that we have animation. So
You can catch a chicken.
yeah, if it would stop to stop running away, then yeah. We might also need to minimap here to do a little bit of cheating. Or we can just update this spawner. So let's say we want a little bit less chickens, but over a smaller area for now. Just so that we can showcase the game.
Okay,
that was
a lot of things.
That was a lot. Our snake immediately got filled. So you can see this here is our snake. Chickens are following us when we move. The implementation here is a little bit basic, but it works for our use case. So yeah, that's working. Now, the thing we haven't solved yet is this is supposed to be a large map, and we're synchronizing all these chickens, and it's a bit wasteful in terms of performance and stuff, and like network traffic. So it's something we're gonna address. I think this was actually 1,000 by 1,000, right? Yeah, we have a big map here. So this is where area of interest or network calling comes in. So how do we activate that?
Setting for starters.
So we go to the network project config, and here are a few things to consider. I think it's not on the network.
Replication mode needs to be.
Replication mode, exactly. So Niels, would you like to explain to people quickly what the difference between delta snapshots and eventual consistency is?
Sure. It's almost in the name. Delta snapshots provide you complete states, or at least the difference between two states, but it's always a complete state. Whereas eventual consistency, you might get partial updates. So it just means that you will eventually have the whole state, but it might not come in one single chunk. And this is exactly what allows us to look at a small part of the world and only get information about that specific area instead of having the whole game world synchronized.
Exactly. So by switching this to eventual consistency, we can activate object interest, which is the interest system.
Yeah, it's really important to note also that object interest is not just about area of interest. Area of interest is just one small subset of interest management, which is a much larger topic. You can also use other mechanics to control what each player actually sees.
Yep, and I think we could actually show that if we find the time real quick, like figure out the feature, how to implement that. But let's start by calling the chickens, because that's our performance issue, right? So we have this enabled, but this alone is not going to do anything. So the first thing we need to do is we need to head to our chicken NPCs. And here we need to configure the object interest. And I think the important part here, I think there's supposed to be a drop down, right, where we give it the position source. No?
On the right side, if you go to the object interest drop down, which is all players on the right.
Oh yes, exactly. So this, instead of all players, which synchronizes it to everyone, we need to say area of interest, of course. And then we need to say what drives the position of the object, right? So where in the area of interest it is. And in our case, it's just network transform. In most cases, it's just going to be network transform. So will this already work, Niels? What happens if you press play now?
Not a lot.
Exactly, right? So we can even showcase this. If we do this and we start a server, so we have one server and one client, and then we make the server invisible. This means we see what the client sees, and now we don't see any chickens. I mean, this is a partial success, right? They're gone. Network traffic optimized. Yeah, but it's not what we want, right? So let's fix that. And what we forgot to do is tell Fusion where is our player at, right? So what area do we want to see?
Yeah.
So for that, we'll go ahead.
We wanted to tell Fusion where we are and how big our area of interest is.
So let's say we have a player area of interest script. I'm gonna put that on the player. And this is gonna just update Fusion with our position. So we're gonna use fixed update network for that, which means we need to be a network behavior. And then interest, it runs only on the server, so it's not relevant on the client. So we only need to set the area on the server we're interested in. And then it's just runner.add player area of interest. And this takes a player ref, which we can get that from the input authority, right? So we can say object dot, not this object, network object dot input authority. What else do we need? Position. So this is just going to be transform.position. And then extend the size of the area, right? This is the radius. No, it's a square, right, Niels?
That's a good question, honestly. Let me look.
I think it is a square.
Thinking, yeah, but you might be right, actually. Let me just quickly look that up.
For now, let's just go with 32. Put whatever you want in here. That's already everything you need. This will just update our interest area as we move around, keep it around the player basically.
Important note maybe also that all these interest management settings needs to be updated every single tick. If you stop calling it, it will go away. So you have to keep updating it.
Yeah, so you really need to put it in fixed update network, no other function, right?
Right.
So if we go to our player avatar, we're gonna put this on the head of the player because the setup here, we have a root object and this doesn't have a network transform as you see. So this is not going to move around, but in here in the script, we're using transform.position. So we need to put it on an object that is actually moving like the head. So we're just gonna put it on here. Let's try again. So now, as you can see, we're seeing a few chickens. So these are the chickens around us. And as we move, or as they move out of the area, they're gonna spawn, right? So this one just spawned in. One important thing to note here is that when we leave the area of interest of the player, so here, what happens here, Niels?
Yeah, it just stops working, or stops synchronizing. So the chicken stop having its network data updated.
Yes, exactly. But they're not disappearing on their own. So if you want to
Right.
have a visual calling, that's something you need to manually add to it.
Yeah.
But the traffic is 0 for those, right? So they're no longer being updated from the server. So only the chickens around us are using network traffic. Now we can actually check that by adding the fusion stats back. Before we were around, I think 1,000 bytes per tick. Let's see how much better we got with area of interest. Looks like it's growing, which I don't know why, but now it's getting stable. So we're about 75, 80 bytes. I think a bunch of this is overhead from like stuff. So we're at a much better space, like place now, right? So this is no longer scaling with the full map size, but just what we see around us. It's gonna give us much better performance. There are less game objects around and everything.
But even here, your area of interest is much larger than your actual view. You always need some kind of buffer area to be sure that things don't pop into your actual visual area.
Like if we check here, I think if you select the camera, you can roughly see our visual area. It's pretty small, right? So it's like this square here. So yes, we're synchronizing way too much here with 32. So, but the bit buffer is nice, but we could even reduce this more. But yeah, this allows us to have all these chickens, and it works just fine, right? So this is really a use case where Fusion is really good at creating these larger sorts of maps with interest culling. Yeah. I think we already set out to do everything we wanted. So we have interest, we have the player camera, we have animation. But I think you mentioned a good point earlier, Niels, that we can also show some other use cases of interest. Now, my idea here is we could add a resource, so a chicken counter, which displays how many chickens a player has connected. And this would only be shown on the UI of each player themselves, so it doesn't need to be shown to other players, right? So that's something we can do, right?
Sure. Yeah.
So for that, we're going to need a canvas. So create a UI canvas. I'm gonna add a quick legacy text because I don't want to import the new text one. Text Mesh Pro, we don't need that. So we're just gonna have chickens. Then, like, how many chickens do we have? And then this thing is gonna be overlay, gonna scale with screen size. Just gonna save you with a full HD screen. We might need a camera to see, yeah. Let's just put this at the top right somewhere. I mean, this is programmer art, so it doesn't have to look good. But let's make it at least readable, right? There we go. Yeah, perfect. Yeah. So this is our chicken counter. We're just gonna count how many chickens we have collected, and we want to update this with a networked value, right? So for that, we're gonna need another script. Let's call it the chicken counter. This is gonna be a network behavior. This is gonna hold the chicken count and update the canvas, right? So we'll need a reference to the text. Public. And then what we will do is whenever our value changes, so we will have a networked value. Let me zoom in a bit so that this is readable. Chicken count. This here is a networked property, and important here, networked state properties, they have to be properties, so you need this getter and setter. I think we have used them before, but we haven't, like in this sample here, but we haven't shown it on stream, so I just wanted to mention that. And then one thing we can do here is we want to know when this changes, right? So can say when this changes, we're calling a function, and for that we will need an onChange function. This has to be static. So Niels, while I code this, can you explain to people real quick what onChanges does and when they should use it?
Yeah, and what it does not. Unchanged is a hook that's called from Fusion, but it's called as part of the rendering. So it's called on the update thread, or in the update loop, which means that it's actually checking changes between two render frames. So it's not tick aligned. It's not based on the specific tick when something changes. That also means that it might miss a change. If you change a property twice in the same tick, then onChange probably won't fire unless the second value is different from the previous render update. So what all this says is that it's strictly for doing visual updates that does not affect gameplay.
Yes, luckily here we have something visual, right? So we're just updating a UI text. So for this, it's perfect.
You really think of
because...
it as sorry, go ahead.
No, go ahead.
Just going to say that you should really focus on onChange for things where you only care about the latest value of the property.
Yeah. So like unimportant visuals, like VFX effects, something like that, like something like this UI text. Do never use it for gameplay, right? So if you want to know whether your character's position changed, do not use onChanged. Instead, use fixed update network and check here whether something changed, right? So this really needs to happen every tick, while this here runs every render. That's very important. It's something a lot of people trip over. So then here, when we get a change, we can use this changed parameter here. So you'll always need to use this syntax here for onChanged, where you say, I have a changed of the chicken counter itself. And then inside the function, which is static, you can access the behavior with the change. So that's us again, right? So we can say chicken count. So this gives us our chicken count here. And then we can just update our text, right? So this has all our variables, including the text. So let's say this is chickens. Text.text. There we go. So this will, whenever this updates, this will get called, and this will update our UI text. So it will always be up to date. Now, one thing we'll need to do is, this is going to be a network object, right? So we will need to find our UI, and there are probably like good ways to do this, but I think we're just going to keep it super simple and have the counter itself instantiate the canvas. Now, this is not ideal because usually you don't want too many canvases around in your scene for performance reason, but we're just going to keep it simple here. We're going to make the canvas a prefab, and it's bound. We're going to instantiate the canvas, right? So we're going to say runner, instantiating runner scene canvas. Then we're going to get the text here. That component in children, right? So don't do this in production here. That's not great code, but it works for our use case. And all of this actually, it doesn't need to run on the server, right? Because the server doesn't have any visuals, and it doesn't need a canvas for each connected players. That would be really bad performance-wise. It's not going to render it, but it's still going to call some stuff on it, just idle around. So we only want to do that on the client, right? So the runner.this client. We're only going to run this here on the client. Same goes for this here. Changed.runner. Change.behavior.runner. Now, we could just put this on the... go ahead.
Now that we're talking about unchanged, maybe we should mention that the object that you get in the changed variable actually contains both the old state and the new state. So you can actually see what has changed if you need to. In this case, it doesn't matter, but that's a fairly common use case.
Oh, yeah, you're right. We can actually show that. So I think what you do is you say change.load old, right? So this would load the previous values. So we can actually add this to our text, right?
Yeah, you can. I think that's an important note maybe also that what it loads is the network properties, not any other random things that are the behavior.
Oh, yeah, definitely. It's going to reset your network state, not anything else. That's always true with Fusion. Same when you do client-side prediction, stuff like that. So keep that in mind.
And also the load old method, even though it sounds a little scary to load a complete network object state, it's pretty quick. It's not actually doing a field-by-field copy, so it doesn't really take any performance.
And here, after doing this, I don't think we need to reset it back, right? So this is going to happen on its own. So you don't need to care about the state after you leave. It's just going to clean that up.
Right.
So we're just going to say, now we have the amount of chickens we have now, and before we have chickens before. This is going to be barely visible because it's only going to change for one render frame. But yeah, we have it. There is a lot of use cases for this though, right? So it's good
But
to
it's
show that.
actually going to stay changed because it only triggers when you change, right? So you're going to see the old value and the new value until it changes again. So that should work.
And this here, correct me if I'm wrong, Niels, it's the changed value is the one from the last render, so from the last time onChanged was called. So
Yeah.
it really detects changes once per update or render. So it's also mostly meant for visual stuff or not gameplay relevant stuff.
Right.
So now we do have this network behavior. It has a network property. We could put it onto the player avatar, but that's not ideal, right? Because if you just put it on the player, it's going to have the same interest as the player, but the player should be visible to other players, right? So what we need to do is put it on a separate network object. And that way we can spawn that for the player and make it only visible for that specific player. So we can create a new network object. Chicken counter. Put the counter on here. We'll need the canvas. So this is going to be a prefab. We're linking the canvas prefab, and text is going to be assigned from code, and the count is we're going to grab the count from the player, right? So this is going to be our chicken counter. And now what the player needs to do, it needs to spawn one of these counters and just make it visible for itself. So what we do here in the object interest, instead of all players or area of interest, we can say explicit players. So this is a different setting. Instead of the position, it uses an explicit call. So you can say this is specifically visible for that one player or something like that. So that's what we're going to use to spawn our chicken counter here. So we're going to put that on the player object. Do we need a new? Yeah, let's just create a new behavior for that. Or no, let's put it on the snake actually, because the snake will also update the counter, right? The reason for that is right now we have this increased snake count, right? So this is gonna get called when the snake gets longer. So I think it's a good idea to have the snake in control of the counter. So let's say public chicken counter.
Maybe just note that having two snake counts is obviously a little bit silly, but that's not the point of this particular demonstration.
Oh yeah, right. This will be duplicated for the own player, which is not ideal. Yeah. There is actually a difference here though, where we have a maximum length for the snake. So the snake can only be as long as we have physical chickens, but we can say the score can go above that, right? So that way we can justify both values, I think.
Sure, fair enough.
So then here, when we spawn the snake, we want to spawn a chicken counter. First of all, this only needs to happen on the server, right? Because everyone else will just get the copy of this. And we can just say, no, we can't assign it here, right? So we're gonna spawn it with runner spawn prefab. We'll need to get it in here. It's gonna be the best way to do that.
Sorry, I was just reading questions. What was your
So we're spawning this counter when we're the server. Now we'll need to link it up to actually to link the count up. I was thinking what would be the best way to do that.
Yeah, you could just call it when you do the actual implementation, I guess. But it's a little bit of a funny use case because I guess normally you wouldn't actually create the UI on the server. But that's just for this example.
Oh no, actually this works. So this is gonna get a bit complicated. Here we are setting the chicken counter to the spawned instance on the server. This is non-networked, and this is only gonna run on the server. So this is server only. What this means is on the server we have this reference. On the client, the snake doesn't know which counter, but it doesn't have to, right? Because we have everything we need to know on the counter. So what we can do is here, we're gonna do a security check here. I think the score should only be updated on the server, but let's be perfectly sure. So if we are the server, we're gonna go to the chicken counter, chicken count, gonna increment this. So this should work. And this is gonna spawn this chicken counter. But now when we spawn it, it's not gonna be visible to anyone because we set this setting, the runner visibility setting, that it's only visible to explicit player. So what we need to do is call runner.add. I forgot how this works. Do you recall, Niels? Set player always interested. Yes, this is what we're looking for. So when we spawn this, we want our own player to be always interested in this network object, and no one else will be interested in it. So we're going to pass in the object.input authority, and we're going to say, yes, we are interested. This is going to spawn this counter just for us. Now, if we return to Unity, we can just stitch all of this together. So the player avatar has a chicken snake. This is gonna need the counter prefab, and this is gonna get spawned. And I think everything else should just work. Well, let's figure out. Let's actually spawn 2 clients here so that we see the difference. And let's update this here a little bit so that something that is a bit more manageable on the server side. I don't know how well CPU will do when we have multiple clients running plus the server, because the server still has all the chickens, even if you have AOI, right? So let's keep this a bit simple. So we're getting something here. Let's check what's happening. So we have a client here. We have a counter of chickens 1 before 0. And then if we collect chickens, number goes up, right? So
you could pick up 2 at the same time. That unchanged would see that as 1 change and not 2. So
the number would still be correct, right?
Yeah, it would still be correct, but it would skip 1 because it would only see 1 change if you pick up 2 chickens in the same tick.
Oh yeah, and now our own player sees 8 chickens. What happens if we switch the visibility to the other client? We see 5
I think
chickens.
the 8 is like from
the... sorry, what did you say?
Is the one with 8? Oh yeah, there's.
So this one here has 11 now, and then when we switch to the other one, this one still has 5, right? So as we can see, we have this counter, and it's player specific. It's just updating this number for us. So this has a lot of use cases, right, Niels? So we can use this for something like health in a competitive game, right? Where you want to know your exact number on the health bar, but maybe enemies shouldn't know that, or like ability cooldowns, stuff like that. There are a lot of use cases for this. It's a great use of interest.
Things in the actual game world that might be out of view, but you still need to know where it is. An objective, maybe you have to get to a certain point on the map, catch a moving obstacle or whatever that's moving around, and need to know where it is, but it's not in your actual view. So yeah, there are many use cases for this particular field.
Exactly. Yeah. So I think we've showed quite a few things, but I also realized we have a little bug here. Well, it's not a bug, it's more of a visual glitch. So one thing that happens when we collect the chickens, like if you look closely, I don't know whether you see it on stream, but they kind of float in from the wrong position, right? So what's going on here, Niels? What would be your guess?
It looks a lot like what the new chicken attaches to your tail. It pops up at 0.0.0 before moving to the actual position in the tail. So you get a little a short glimpse of a chicken in the wrong location.
So let's investigate what's going on here. So we're moving these on the chicken snake, but what we did here to improve performance is we're only moving the ones that are visible, right? So we're only moving the parts of the snake that are visible. Just why would you move the rest? But then when we pop them in or out, something goes wrong, right? So the interpolation is off. Now, I think what we can do here is when we spawn them in at the correct position. So this here updates the visibility of the segments and makes them visible if the the count increases. So what we can do here is we can just use the teleport to smooth that out, right?
Yeah, what that does is it moves not only the actual snapshot position, but it also resets the interpolation. So that it doesn't try to interpolate from an old incorrect value up to the first known valid value.
Yeah. So we're gonna need the network transform here, right? The component network transform, and then we're gonna say teleport to position. And I think we can just keep everything.
You can also use teleport to position rotation to get both the position and the orientation correct.
Oh, then let's do that. Go to position rotation. Then we're just grabbing, like, let's say this is position, passing in the position and the rotation here.
Yeah, it's controlling, I think.
Oh, previous dot rotation. Then we remove this, right?
But okay, sure.
Is there something wrong with this, or?
I was just wondering if the orientation you get is the correct one. Shouldn't you use direction, like turn dot forward?
Oh, this was so. What this does is we're getting the rotation, then we're setting the rotation. Oh, and then we're calculating the position, and this uses the rotation, right?
Okay, sure, sure. Yeah, sorry.
So we actually no, you make a good point. We need to set the transform here, right? The rotation, because else this direction calculation will be wrong. So we're rotating, then we're calculating the target position, and then we're just calling this again, but this should be fine. Like, we're setting the rotation twice here, but it's not causing any damage, right? It's just fixing the interpolation. This should work. So now the chickens should no longer. Yep, I think the popping is gone. Yep.
Yeah, it's gone.
Like you could add a little animation where the chicken actually spawns at the position where you collect it and then it runs back to the snake or something like that. It would probably be a bit nicer.
Room for improvement.
Yeah. I think you also had a nice idea to make this a bit more PvP, Niels, right? So what could we add there?
I guess we could add some way to steal chickens from your opponents, maybe. In typical snake fashion.
Yeah, that would be a nice idea, right? You can steal them, but maybe you don't want to touch the head or something. But
right.
I don't think we're gonna have time today for that, or would you like to give it a spin, Niels?
I have what time are we at?
It's 10 past. So we have another 20 minutes if we want to give it a go.
Yeah, maybe just see if there's anything in. No questions in particular.
I haven't checked the chat for a while, and this is just to show that this is actually working in multiplayer, but I forgot where I walked with the other player. So this is not a great showcase.
There's a suggestion that says trigger zone for speed bonus. That might be an easy one to throw in.
Oh yeah, so if you walk over a certain zone, you get a speed bonus. That's something, yeah, that's a cool idea. So do we want to try to figure out how we can steal chicken?
Sure.
So then what we'll need here is, right now we're collecting chickens via triggers, right? And this already works for the NPCs, but it also needs for the player to work. So I think for now what we're just gonna do is on each snake part, we can add a trigger collider, right? Oops. Trigger.
So you get the entire tail or just the one that you actually touch?
I mean, it would be nicer if you just stole the ones which you touch, right? So not everything. Or what do you think? Or do you just eat the entire snake? I don't know. Well, eating the entire thing is gonna be easier, so maybe let's start with that.
Yeah, sure.
So this will need a sphere collider. So this is a case where we're using 3D colliders here. It's just for simplicity because this is like a jam game, but in like a real game, you could use 2D colliders for something like this, right? Because this game, it's simply 2D from the interactions we have right now.
Yeah.
And let's give this another tag. Say this is a chicken snake part. And I think it's in the chicken head. No, it's the chicken collector, it's called. So this one, when we enter a trigger, well, actually, when we stay inside the trigger, if it's an NPC, then we despawn it and increase snake count. The reason I used on trigger stay here is because of prediction, but in this case, it isn't necessary.
It's always safer because on trigger enter is short-lived. It's one render frame. If you miss it, you miss it.
Yes, and
trigger stay is always safer.
And it's a bit complicated when you roll back the physics engine, right? So when you have two objects and you roll them back, that can actually cause a trigger, right? So that can cause a trigger enter for that rollback frame on the client, even though they might have been already in contact for a while. So you can get false positives. This is kind of stateless, so it's always correct. That's like the idea here. Compare tag, in case you're not aware, it's just a way to compare Unity tags with better performance. So you should use that instead of comparing the strings. And if the other is a chicken snake part, it means we will want to know about their chicken snake, right? So this is going to be a bit hacky, but what we're going to do is we're just going to skip up 2 in the hierarchy and we get this component here, right? So we're going to say other.transform.parent.parent.get component chicken snake. And we already have our own snake, so that means we can just steal their chickens, right? So this other snake, it has a chicken count on it. Snake count, I think. Network property. Yes.
Could also steal the actual game objects. That would
well,
make
that's
snake shorter and shorter. They wouldn't be able to grow it.
But that's like where the stuff becomes very complicated, right? Because now we're dealing with network state. So if you were to like reparent them, you would need to make sure that that's handled correctly over the network.
Yeah.
So one thing to make this super simple is abstractions which simplify the network state, right? So here the chicken snake is really just how many parts do we have? So it's super simple, right? It's just an int. So this is like something you need to think about when you create your game. Like, how can I simplify my network state to the minimum? So for instance, if you have a weapon, you could like parent that to the player's hand, right, as a game object. Or maybe you could just synchronize an ID for which weapon the player has, right? So it's things like that, basically.
Yeah.
So what we're going to do is...
Yeah, it's good exercise to always think in terms of visuals as one thing and the actual logic behind it as a separate thing.
How did you increase snake count? So here for each chicken on the other snake, we are increasing our snake count. The reason why we're not just adding the numbers is because we have a cap here, right? So that's why we're doing this manually. We also want this stuff here to trigger. Oh, actually, let's add a function to reset the other chicken after. So reset sets snake count to 0, chicken count to 0. So that way we can safely reset the other snake to 0, right? So snake reset. So we're getting the count from the other snake. We're increasing by that count like X times, and then we're resetting the other snake. So this should allow us to steal chickens, right? Let's try.
Hopefully. The stream froze for me at the moment. I think it's a local thing here.
But... are we back or?
I think that's just me. It's
okay. Good. So to show this, we will need 2 clients, 1 server. And let's take control of one of the clients. Oops.
He's stealing his own chickens.
Yes, and we are getting a null ref here, so something is going very wrong here. Oh,
server.
do you see the problem?
Yeah, it's the wrong chicken counter, I think.
So
UIs.
so the reason why we're getting
that UI doesn't exist on the client, right? That reference.
exactly right. So we forgot to add the if runner for the server check here. So this is gonna make this safer. But then there was another point where we're stealing our own chickens, right? So what we need to make sure here is that if the other snake equals the chicken snake, so our own snake, and we don't want to do anything. In theory, this shouldn't happen because the chicken, they keep distance to each other, but maybe that distance is too small. So no, not 21 clients. That would be a little bit much. So why is our camera? Huh? I don't know what happened here, but so we have two players, each has a bunch of chickens. If we run into the other player, we steal their chickens. If we switch to this guy, very little chickens. Duck, we have a lot of chickens. Oh. Yeah, you need to be careful, right?
I think this feature might need a little bit of tweaking.
Yeah, it's also how the snake just one straight line. So what would really help here is if the chicken walked to the correct position from where they're captured instead of just teleporting. So yeah, there's a lot of room for improvement, but I think we also showed a lot today. We handled animation, we handled AOI, we went over how to use the network debug start in Fusion, right? So it's a good starting point. Yeah. So I think we're gonna call it for today, unless you guys have any questions. So if you have any questions left for us, could be about anything Fusion or about the chat, like about what we did today specifically, then please post them into the chat, and else we're gonna end the session here.
Yeah, I think we're good.
Yeah, I think so. Well then, first of all, thank you all for attending today's stream. I hope you learned a lot about using Fusion. Thank you so much as well, Niels, for being the Fusion expert here and teaching us so much about how this stuff works.
You're welcome, and thanks for watching.
Then have a wonderful day, everyone, and see you next time.
Cheers.
Cheers.